Hello everyone, and in this video we're going to be solving a problem from the USA team selection test from December. And it was written by Evan Chen himself, which is really interesting. But anyway, here's the problem. We have a triangle ABC, and its incircle touches the sides at D, E, and F. And I is the incenter. And then P is on line AI, such that DM is equal to MP. And then Q is on the incircle, such that angle AQD is equal to 90 degrees. And then what we want to prove then is that this angle here, angle PQE, is 90 degrees. And I also forgot to mention that AB is less than AC, because that will be important in the problem. And P is inside the interior of the triangle here. All right. So how can we get started on this problem? Well, we see points D and E, and we're trying to relate them to point P somehow so we can get some nice relationships. And we end up seeing that D, P, and E could be collinear. They might. So conjecture is that D, P, and E are collinear. So let me draw a dashed line to indicate this. So how would we prove this? Well, suppose that it was the intersection of AI and DE. And then we have this line MP here. And we want to show that if this P prime is the intersection of AI and DE, that DM is equal to MP, as that will be enough to prove it. Seeing the line MP prime, given this intersection, it kind of seems natural to kind of extend it to the other side. And then we have a point N here. Now, the key claim here is that N is the midpoint of AB. So BN equals NA. And I made a previous video on this, but the angle bisector here, the touch chord and MN all concur at the same point P prime. So MP prime must go through the midpoint N. And because MN is parallel to AC, this means that triangles DMP and triangle DCE are similar. However, we know that DC is equal to CE, which means that DM equals MP as we need P prime as we needed. So now that we know that all of these guys lie on the same line, we can get rid of the point N now. We now want to try relating something with this angle. We have something centered at Q, a right angle. So we try thinking, is there another right angle centered at Q? Well, there might. Actually, yes, there is. So we have, if this point here is a point X, then angle DQX is equal to 90 degrees, as we know. However, we know that from a previous video that I created about homosity, that DM equals MX. So that means that angle DP prime X is equal to 90 degrees as well. So we have some right angles, so we can start doing stuff. I'm erasing all this stuff because we already proved our conjecture that DP prime and E are collinear. So now that we know what DQX is, and then this point here is P, we want to prove that angle PQE is 90 degrees, which ends up being angle DQX. But note that we also have an angle here, so we'd be kind of happy if we can show that DQE I'm using directed angles here to avoid like configuration issues that we might come into, where directed angles is just like positive theta if the points are in clockwise order. For example, EQD is equal to a positive angle, while DQE is negative. EQD is positive while DQE is negative, and we take angles modulo 180 degrees. But anyway, back to the story. And we also want to prove that it's equal to angle XQD. So we already know that angle DQX is equal to 90 degrees, and angle DPX is also equal to 90 degrees because dm equals mx, as we said, which means that dpqx is cyclic. dpqx is cyclic. So let's go ahead and evaluate each term separately. We have that angle XQD, or XQP, sorry. So XQP is equal to angle XDP, but note that XD is tangent to this incircle here, which means that since it's angle XDE, which is, and this is where the fact that P lies on line DE comes into play, and this becomes DFE. Now we want to focus on angle DQE, but we already know that angle DQE is equal to angle DFE because of the cyclic quadrilateral FDQE, because Q is on the circle. Therefore, we have that this is true. So subtracting out this angle here gives that angle PQE is equal to angle DQX, which is 90 degrees, as we need. And by the way, just a little side note here, the initial wording actually got rid of this statement here, AB is less than AC. The fact where we use that AB is less than AC comes down to P being inside the interior of the triangle. If AB were greater than AC, then P would be somewhere out here. So, and Evan Chen wanted it to be such that P was in the interior. So we asked the people to prove that either angle PQE was 90 degrees or angle PQF was 90 degrees to avoid configuration issues as much as possible. So thank you so much for watching. I hope you enjoy.